Hello everyone. The aim of this recording is to give you an overview of a chapter by Smith et al. Called Goals of an Organic Synthesis. I will share my screen right now and I will talk you through what I've prepared. Just as a reminder, the chapter is free to download, but you will need to have a free ASP publishing personal account to access it, to access this particular chapter. If you don't have one, you just have to provide a few details on the RSC website to open it. If you have any questions, any problems, please email me and I will try to do my best to help you. The book itself is now over 20 years old, so definitely the information it contains is to a certain extent out of date. However, it provides an excellent historical overview of what it is organic synthesis, of the background of the reactions, the chemicals, the compounds that pave our understanding of what it currently is organic synthesis. At the end of studying this chapter, at the end of studying this topic, you should be able to discuss the various roles of organic synthesis and the various ways you can judge the importance, the worthiness of a particular organic synthesis, and also provide examples of some key organic compounds of the historical synthesis of key compounds that have pharmaceutical, biological, or industrial applications. The book starts with talking about usefulness of organic synthesis as a way to measure how worthy it is. And this section talks about how the origins of organic synthesis were focusing compounds that we already knew were useful and that they were available already from natural sources, but they were either very difficult to extract or it was needed a large quantity of that natural source for them to be extracted. And it is example, for example, of indigo or alizarin, red, purple dyes that were for many years, even in ancient times, already known, but difficult to extract in sufficient quantities and only reserved to those in high positions, and how synthetic organic chemists in the second half of the 19th century were able to identify the individual components that provided the dyeing properties of those natural materials and synthesize indigo, different indigo dyes or alizarin, and how that synthesis meant that products that were before very expensive and only available to a selected few became widely available. It also talks for a certain length of time of Korana's synthesis of a fragment of DNA. He achieved a Nobel Prize for this work in 1968, if my memory serves me right. And how his work in synthesizing a fragment of DNA, synthesizing RNA chains with the help of enzymes, all that work paved the way for the development of genetic engineering, and it is considered it gave us the fundamental principles of our understanding of molecular genetics. It mentions anti-cancer drugs like Taxol or immunosuppressant agents, or prostaglandins that, again, the synthesis of compounds that were known to have positive effects, pharmaceutical effects, or something like the synthesis of ascorbic acid in the mid-1930s, which is one of the essential vitamins, and its lack produces scurvy, and how the synthesis of ascorbic acid meant that scurvy was not a problem any longer in places or in situations in which access to fresh fruit and vegetables was difficult. So section 1.1, it's about how, the immediate usefulness of an organic synthesis. However, in section 1.2, it challenges the notion of only focusing on the importance of an organic synthesis by looking at how useful it is in the very immediate future, and how there are other ways of assessing. There might, if we only focus on what is immediately applicable, we might be missing out in potential benefits of a particular organic synthesis, and talks, for example, about the efforts in synthesizing isoprenoids, a set of compounds that until the 1950s were naturally occurring compounds. They were widely spread, but it wasn't very clear the role, and they were considered by many just superfluous. However, now they are actually, since the 60s, we now understand better their role, and for example, the role as hormones. So the book argued that without having kind of thought, looking further, further ahead, rather than the immediate, right here, right now, this is useful or not, to assess the worthiness of exploring particular synthesis, how it is worth thinking in a holistic way. This section has a standard part on pheromones and chemical signaling, which is interesting, but I particularly found it a bit long. I felt that it was deviating a bit from the initial topic of this section. I would be interested in hearing your opinions about it. Section 1.3 talks about the worthiness of an organic synthesis as a search in itself. And it talks about the exploration of the synthesis of analogues to prepare potentially useful compounds from a particular compound of interest. And it touches briefly upon the relation between organic synthetic chemistry and other branches of chemistry, like, for example, computational chemistry and modeling, to model those potential new compounds and to model their potential mechanism of reaction and their potential behavior. And some of the chemicals and pharmaceutical drugs mentioned in this chapter includes, for example, anti-malarial drugs. It also talks about azo-dyes, which are now a key importance and one of the most common dyes used in the textile industry. That again were built on this exploration of the azo group as a building block to construct the different dyes. Section 1.4 talks about the use of an organic synthesis as an instrument of exploration, and it explores how when attempting synthetic organic reactions, we can explore new methods, new routes to prepare known compounds in a better way, more environmentally friendly way, with less health and safety implications, cheaper ways of producing already current compounds. And it talks about misfires and what happens when a synthesis goes wrong, and how in itself that is a result worthwhile exploring, and how many organic syntheses, which currently well established, and many important discoveries in the field of organic chemistry started as an initial failure of the original synthetic plants. And he gives the example of Gomberg, early 20th century, who was aiming to synthesize a particular compound, hexaphenyl ethane, and ended up discovering a whole new class of organic species, stable radicals, which until then had not been stabilized. Section 1.5 starts with a quote from Berthollet, and chemistry creates its own subject, and it talks about the role of organic synthesis in developing our understanding of the dependence between the properties and the structure of organic compounds, and how you can use organic synthesis to create particular compounds which can serve as models for investigation. And it talks, for example, isomers, our understanding of isomers or our understanding of aromaticity were built on this synthesis of organic compounds, synthesis of different compounds to explore whether they were or not aromatic. And it talks about the continual expansion of the objectives studied by organic chemistry. That and it has this lovely concept that organic chemistry probes the unknown. So every new synthesis, every time a new synthetic method is trial or a new compound is attempted, furthering our understanding of the subject. And many of those seemingly theoretical and not particularly applied projects can end up yielding really important compounds of huge interest. And mentions, for example, the exploration of fluorocompounds and the attempts to add carbon fluorine atoms to a carbon structure, and the attempt by synthetic organic chemists to increase the number of fluorine atoms of in an organic compound, and how that goal was initially academic, just for the sake of it, trying to push how further we could push the boundary of organic synthesis, ended up to the discovery of a whole type of plastics, fluoroplastics, for example, PTFE, which are of hugely commercial interest. I wanted to finish with this quote by Berthollet, which talks about chemistry, but I think it can be specifically applied to organic synthesis. Chemistry creates its own subject. This creative ability, similar to an art, is the main feature that distinguishes chemistry from the natural and humanitarian science. And if that quote is true in chemistry, it's definitely true in organic chemistry, in organic synthesis. Organic synthesis is about creation, designing new compounds, building new synthesis, and that's this role of exploration is what makes it such a fascinating area of chemistry. So that's all from me. If you have any questions or comments about the chapter or about the presentation, just let me know, email me, or post in the discussion board from the Blackboard. I will stop sharing my presentation. And I hope this has been useful. Please let me know if these overviews of the chapters, I'm going to ask you to read a few chapters throughout this module. Please let me know if you find these overviews useful for breaking down the chapters into more manageable chunks by providing you a structure. That was definitely my aim, and I hope it was useful. Thank you very much for watching.